So, hi everyone. Let's begin. Woo! Now I'm going to ask you to clap for the R2D2 hills. I have to. Come on, give me claps for the R2D2 hills. Come on. Yay! That's it. You've done your duty as a great audience. I love you already. So, hi, my name is May. I'm a software engineer. I'm a backend developer at AppsFlyer. And yeah, I'm a huge Star Wars fan, if you've noticed. Before I joined AppsFlyer, I worked in many different places. And every single place that I ever worked at, I had to learn a different programming language. And it was easy. It was just, on the flow. And it didn't matter which language it was okay for me to learn that language. So when I joined AppsFlyer and they said, okay, now you're going to have to learn Clojure when you join us, because that's the main development language they use at AppsFlyer, then I was like, okay, another language, another syntax, right? Wrong. Very, very wrong. And I'm going to tell you a little bit about my journey towards learning Clojure. And it was a crazy journey, to be honest. I started with this great, awesome book. It was written by Daniel Higginbotham. He's a wonderful author. It's kind of funny. If you want to read a programming book and laugh, then that's your book right there. But not only that it's funny, it's also a great introduction to Clojure. It has all the fundamentals of the language. It explains beautifully how you should start thinking about Clojure. So, yeah, the next thing I did was this website. That's a great website. It's called For Clojure. It has many different questions in different difficulty levels in Clojure. So what it will give you is an opportunity to start to be familiar with the functions that Clojure has to offer, which is great because once you start coding in Clojure, the first thing that you're going to be hit with is the syntax. It's crazy syntax. We're going to see a few coding examples, and you're going to be wowed by it in just a bit. So after I did these questions and the book, I still didn't feel that I can speak Clojure. I wasn't there. I mean, I thought that I speak a little bit of Clojure, but not enough. Or just like Yoda once said, and I'm sure he said that at some point, much to learn in Clojure you still have, my young Padawan. And so I still had to learn more Clojure. My journey had just begun. Before I will talk about Clojure, let me tell you how my journey with Java went on, or how I learned Java over a weekend. Now, okay, I did not learn Java over one weekend. I learned a lot about Java, or how to code something in Java over one weekend. How did that happen? So it was a Friday morning. I got a call from an HR. She said that they have an opening in Java in a startup, and she wanted to schedule an interview for Sunday morning because I'm from Israel. I don't know if I said that. I'm from Israel. And in Israel, we work on Sundays. So she scheduled the interview to Sunday morning, and I was like, okay, I don't know Java. Let me see what I can do over one weekend. And this is what I did. I developed a calculus game. So what is this game? What you're about to see, and I'm going to show you a little demo of the game. What you're about to see is a student trying to avoid exams because, well, students. So why was it good? Before I'll show you the game, let me tell you why it was good for me to try and understand the Java world over one weekend by developing this game. So the first thing was, I knew how a game works, right? I knew that I needed a player. I knew that I needed something to move to handle the arrow keys. And so I was able to ask my own questions. I was able, over one weekend, to understand the fundamentals of object-oriented programming. Also, I was able to start to understand how to handle threads in Java. And it took me just one weekend because this game was a simple game. Another thing I was able to understand over one weekend was how to handle files and the file system. And I mean, it was fairly easy to get all these ideas over one weekend and to have a working game in Java by Sunday. So let's see the game. All right, remember, that's the calculus game. There's the student. That's the exams he's trying to avoid. Isn't that awesome? But yeah, you know what happens to all students? Eventually, boom, that's it, he fails. So, I'm sure you all want to know what happened with that job. I got the job. Woo! All right. Yeah, so why was it so good? Like I said, it was so good to do just this simple game over one weekend because I was able to not concentrate on the game, but I was able to concentrate everything in the language and not on the software that I was trying to develop. So let's go back to Clojure. Let's talk about the first game I ever written in Clojure. So I went back home one day and I said to my friends at the office, listen, you guys, I'm going to come back on Sunday. You're going to see a game written in Clojure. Oh my God, it's going to be an awesome game, just like the calculus game. You know how I am. I write awesome games. So I was like, OK, let's see what I can do. So are you ready to see the first game I ever wrote in Clojure? I'm sure you are. That's it. It's just nothing. No, but really, this is the first game that I was able to develop in Clojure. So what do you see over here? That's the chicken and egg game, and that's all there is in this game, just a chicken and egg. Let's see how it works. Yep, whenever you press on which button, it's going to be the same result. It's you are right, and then you are right again. That's it. That's the game. And I mean, I was super happy about this game until, okay, I have to tell you this story, right? I had this game, I'm super excited about it, and then my 10-year-old neighbor, she comes to my place, she's like, hey, May, you said that you're going to develop a game, I want to play. And I said, all right, hey, play this game. And then she looks at me and she's like, that's not a game. I'm like, yes, it is a game. You just don't understand it, little girl. Okay, that's a game for grown-ups. Yeah, grown-ups will enjoy this wonderful, amazing game. And I was lying. I was lying to a 10-year-old girl, which is not nice. And I knew right there that I had to rethink what it is that I have to do. It's not a game. I have to write a real game because, let's be honest, it's a window with 2 buttons. So I could literally write anything I want in this, and it's not a game. So why was it so hard? What was so different? What was different about Clojure? Why was it so difficult? Well, the first thing is this. And if you don't know what immutability is, it means that you didn't get the joke. And I hope that this is the reason you're not laughing, because this is super funny. I mean, so immutability means that once you set a value to a variable, you cannot change it anymore. You will only be able to use this value, but not to change it. And this is a big thing for programmers who already have background in programming. We are used to changing values of variables. We're used to put something in a variable and then, play it around, edit the value as much as we want, and then that's it. We have whatever it is that we wanted to do. But now, I don't have it in Clojure, which is weird. If the player needs to move from one place to another, and the value of the position of the player needs to change, how do I do it if everything is immutable? Think about it. The next thing is, where are they, those objects? Where did they go? I mean, that's another thing. We are so used to doing something with, let's say, objects, classes, and for me, it was a big thing to not think about game with objects. I mean, I have a player. The player is an object. The player will activate the function it needs on itself. That's it, done deal, right? So if the player needs to run, it's going to be player.run. That's it. But now in Clojure, it's going to be different. It's going to be functional programming, which means there are no objects. It's going to be functions, calling other functions, calling more functions. So I'm sure Yoda said that also at one point in his life. He said, if no mistake you have made, losing you are. A different game you should play, which means a different language, different syntax, different way of thinking, different game. OK, now I had to stop and rethink what it is that I have to do. So, are you guys ready? Yes, you are. You get it? You get it? Clojure star? I hope you get it, because if you don't, you're not a Star Wars fan. Get out. No, I'm kidding. I'm kidding. Stay. Don't go. So, yeah, my journey to Clojure star. Let's talk about it a little bit. How did it start? So you have where it is that you want to go. And now all you need to figure out is how to get there. The first thing that I advise you to do is to understand the 2D game structure. That's it. And what does it mean? It means that you want to understand the structure of simple 2D games. Let's take a look at it. So let's start with the framework functions. And these functions are the ones who handle everything that has nothing to do with the logic of the game. It means that if you need to have connection to the network, if you need to load images, if you need to handle the input from the player, this is where you'll do it. Because moving, using the arrow keys or swipe, only gotta handle it once, not more than that. So these are the functions that you're going to put in the framework functions. Next thing that we have is game-specific functions. What does it mean? All of the logic of the game. So it means that if I want my player to be an infinite runner, then I'm going to have to say that if I press, let's say, the space bar, then the player will jump. Or if it's a maze, then we will have to do whatever it is that happens if you press the arrow keys. But we're talking about results. We're talking about maybe how do you win a game? How do you move, right? So this is where it will all be. The game-specific functions, we're talking about the logic of the game. So last thing, assets, right? That's it. It's kind of obvious what it is. So yeah, that's it. These are the 3 parts of a basic 2D game. And the reason that I'm showing this to you is I want you all to remember that when we're going to look at code in a few slides from now. Remember this, because what you're going to do is to look for these functions in the code that you're not familiar with. But once you know what you're looking for in code, even if you've never seen this code before, it will make it easier for you to understand this code, right? Even if it's written in Clojure, because you know what you're looking for. That's the whole idea. That's the reason why I show you these functions. Not because I don't think you know how to write games or anything. It's just because I want you to use this knowledge that you already have into learning something new. So, the game loop. The first part will be initializing the things in the game, right? If you need to upload, like to load images or to set the values of the player, this is where you'll do it. Then the next thing, once the game starts, you have the game loop. And remember, I want you to remember these 3 steps because we're actually going to use them in just a bit. So first of all, we have to get the user input. Then we're going to have to update the values of the game entities. And remember, how do we update things if it's immutable? We'll see it in just a minute. And then we have to redraw the values to the screen, right? Because if the player moved, we want to update the value of the position. And then we have to redraw the player to the screen. So, next thing. We now understand the basic 2D game structure, what it is that we need to do, which is different than other languages. We need to find code already written in Clojure. So that's the big part that is different for me than writing games in other languages. In other languages, I was able to just start writing, look at examples, a little bit here, a little bit there, and it was mostly okay being done by me, even if I wasn't completely familiar with the language. But with Clojure, I felt that I wasn't able to write anything from scratch. I really needed to look at examples in order to understand idiomatic closure. I had to understand the way of thinking, like the functional way of thinking. So in order to do that, I just went and I took a game already written in Clojure. There aren't many of them, but the ones that are out there are wonderful. So first of all, find a simple game. Okay, find like a Pac-Man, a Snake. Don't go like crazy 3D open world games. No, find something super, super simple, a maze, whatever. And the second thing is, you want to find a game that you know and love because it will make you happy. That's it, no other thing there. Just, it will make you happy. And it is important that the game will be simple just because you want to concentrate on the language, not on the game. Okay? All right. This one. So this is an amazing library. Okay? I highly recommend to just anyone, even if you already know Clojure. I think this is a great library to use for writing games in Clojure because it wraps Java libraries for writing 2D games, and it's fairly easy to start developing games in Clojure with this library. And this is what I used. Next thing is this great tutorial. It was by James Trunk, and the link to the code is right here in the presentation if you want. This is the code that I found. Remember I told you what you need to do is to find code of an already written 2D game. So this is the game that I found, cow with apples. I mean, it doesn't even matter what game it is. It just has to be simple. Let's take a look at the game itself. So yeah, it's just a weird cow collecting apples, but it's a game, all right. Yeah, it's more than a game than what I had with the 2 buttons. So, okay. I found a game. I found like the code. I started to take a look at this whole thing, and now what I realized is this. I have the background image. I have cow. I have apples, and the apples, let's see that just once again so I can explain what it is that we're going to look for. So the cow is now going to start collecting the apples, right? And you see how the apple disappears from the screen every time she collects them. So remember that, because we're going to have to look at code implementing these things. And that's it. Just moving from side to side, collecting apples, and then once you collect the apples, it disappeared. Okay? So yeah, we found the game. Now we're going to have to map the game. Remember how I said, remember the 2D game structure. Remember what it is that the cow is doing. Crazy. She's collecting apples. That's what we're going to do. We're going to find familiar things in an unfamiliar code. That's it. That's what we're going to do. So, object out, key value map in. Let's take a look at some code. All right. So I hope you can see it. Yeah. Okay, you can see everything. It's a little bit of the parentheses is just out because there's so many of them. Oh my God. But yeah, so what do we have here? Here we're defining 2 maps of one is an apple and the other one is a cow. And then we return a vector of these 2 maps. And these are the game entities. What does it mean? It means that we have the apple, and we're going to save the values that we need for the apple. We have the position, and we have the image. And let's say we want to add something else for each entity. That's going to be super easy, right? Even if you've never written Enclosure, what would be the thing that you'll immediately do? You'll just add more values over here, just more keys and more values, and then that's it. That's so simple. Oh my God, you have written your first line in Clojure just at this moment. Isn't that crazy? And so the next thing that you have over here is the cow. This is the player. So we identify what it is that we're using right now, if it's the player, if it's the cow, just by another key. That's it. We don't need objects. Isn't it crazy? We don't need objects. It's crazy. And so we return a vector with maps, with all of the entities' maps. And that's what we're going to do. We're going to use all of these together in the game. Let's see how it works. So, functions as values. OK, we're going to read this code slowly together and understand what's going on here. But the first thing that you're already familiar with is the entities. We all saw what it contains, right? We have the cow and we have the apple. It's a vector containing all of the entities of the game. We only have 2, but if we need more, isn't it easy to create more? Yes, it is. It's pretty understandable. So let's talk about this code. It's kind of understandable if we're reading the name of the function, move and collect. It means that this is the entire code of the cow game. She just moves and collects apples, and then that's it. Awesome. So we get the entities, and then we have 2 functions that we're going to start calling. We have the map function, and then we have remove collected object, which is kind of self-explanatory, but I'm going to dig in even further. So what happens inside this map function? Another function, because it's Clojure. Over here, we can see that inside the function, we're using each entity separately. So that's fairly easy to understand, right? We got them plural, we got all the entities together, but now we're going with each entity separately. And now let's see what we do with each entity. So what is it that we're doing? First of all, we want to update the player position. We want to check if the player moved from one side to another, or maybe 1 pixel to the left or to the right. We're going to update the position over here. And then, once we have the result of the new position, what we want to do now is to update if there was an apple collected, right? We had the cow. She moved a little bit. If in the new position, the cow took an apple, now we're going to have to update it. So it means that this has to happen first, and the result of this will have to be inserted to this, because we are dependent on the result of this one, right? First of all, the position, then we need to update if it was collected. That's it. Isn't it awesome? It is. I know. It's crazy. I love it. I love it. And I didn't like it before, I swear. I really didn't. But then I fell in love. I fell in love with Clojure because it's so simple once you get it. Yeah, once you get it, it's simple. It goes like this. You're like, what is it? What is it? Oh my God, I got it. So that's how I felt. I hope you'll do it too. I highly recommend. So now that we're done with all the entities from the game, the next thing that we want to do is to update if there were any entities that we need to remove from the screen. Remember, we collected an apple. Now that we are done updating all the apples, if they were collected, now we will need to update from the screen just to remove them, OK? And then that's it. That's the entire code. That's all we have. And so what is the next thing that we want to do? After we mapped the game, and we are pretty much sure that we realized what happens in this game, we need to add a feature, because this is how you'll be sure that you truly understood what's going on in the code. If you were able to add something to code without breaking it, it means that you truly knows what's going on in this code, right? So add a feature, not a bug. It's a serious thing right there, because you want to make sure it still works. If you don't have the cow anymore, you broke the code. So let's see the first thing that I added. Remember, we had a cow. She was only able to move in 2 sides. So that's the first thing that I wanted to handle. I just wanted to add more sides, more directions for this cute cow. And also, I got rid of the cow. I'm sorry, I hated it. So this is sort of a Clojure astronaut collecting tiny spaceships, I guess. It doesn't make a lot of sense, but I love it. So I left it this way for you guys to enjoy. Let's see what it does. So first you can see that I changed the images of the game, which means that I was able to go to dig through the code and understand where the images are located, where is the part that you load the images. That's the first thing. Next thing that I did was to add directions. Now let's see this cutie in action. Yeah. Woo. And then that's it. That's the game. I know, I think that's what's going to happen is that you will never believe me when I say games anymore, right? Because my games aren't that fun. I don't think you're like I'm going to be like, oh, that's a game. And you're going to be like, is this a game or just buttons? Okay. So, okay. Before I'm going to show you the next slide, I want you guys to clap, and then I'm going to show the slide. Clap, clap. Come on, come on, come on, come on, come on. It's a Pac-Man. I love it. Isn't it awesome? Aren't you happy that you clapped? It deserves your claps, I know. So, yeah, the cow is not a cow anymore. Now it's a Pac-Man that evolved, over time. I added different things each time as I learned Clojure. Every time that I knew something new, like when I learned something new in Clojure, I was able to, insert it into my game to help it become more a real game. And adding the directions was the first step. But then what I did is I added more entities. You see, I also have cherries right here, if guys in the back can see. We have 2 different entities. And then the next thing was to add boundaries so the Pac-Man won't be able to get out of the screen. Also, I wanted the Pac-Man not to be able to walk into these. And so adding logic in a language that I wasn't familiar with, it was more helpful than anything because I had to really think, how do I handle the player? How do I activate the functions? If it's not the object activating functions on itself, if it's functions doing things on the data, that's the big difference that I had to make in my way of thinking. And it really helped me because that was simple. I knew what I want to do. Once I knew what I wanted to do, I was able to ask my own questions. And once I found the answers to my questions, the learning was much deeper. So, yeah, that's it. Do you want to see it? Yeah, of course you do. Woo! You see, it doesn't disappear. And of course, so now, going up, and we're gonna, I wanted to show that there are no boundaries. And it's a bit moonwalking because, it's walking to the back. I didn't solve this yet, but it's okay. Clojure going backwards, it's a feature, obviously. That's it. That's the Pac-Man game. Oh my God, I love it. Thank you. So, the next thing, the next thing that you want to do after you added things to the current game and you are sure of how to do things in Clojure. I mean, not sure. Okay, we're never sure. We are more confident to do things now in Clojure. For me, the next thing was to not to use a library already prepared for me. The next thing that I wanted to do was to write my own game in Clojure, and I wanted to see if I can wrap the Java libraries myself, which is what I did. I wrote a completely new game, and I wrapped the Java libraries myself. It was an interesting thing to do, because then I was able to realize one of the biggest, most important things that Clojure has to offer. Because Clojure runs on the JVM, it means that I can use all those libraries that the JVM has to offer. And it means that I can use all this code already prepared out there for me, and I can do it in the functional way. And it's amazing. And this was a big part of my journey, to wrap my own, to wrap it myself, to wrap the Java libraries myself. It was awesome. I truly understand more things about the way Clojure goes right now. And it's important. So, you want to see the game? Ah. Yeah. So here's the code. That's also the code to the game. What you see over here is parenthesnake. Because Clojure has all these crazy amounts of parentheses everywhere. They're just everywhere. And so you have a snake. It's a scattered parentheses. And over there in the corner, it's the parentheses that we already collected. It's balanced. So you can collect val in parentheses with the snake game. And it's a real game right there. That's a real game. You can play with it. Let's see. Woohoo! It works, right? Awesome. So yeah, that's the game that I wrote in Enclosure. The snake was a bit different than the cow game and everything. So if you'll see the code, I can't say that it's the best code ever written in Clojure, but the fact that I was able to do it by myself, it meant that I truly understand quite a few things in Clojure. It was very, very important part of my journey into learning Clojure, because I know I am now developing in Clojure for almost a year in AppsFlyer, and there are a lot of things that I can do. But when I had to stop there and think about logic written in Clojure, it was completely different than the way we handle data in AppsFlyer, right? It was just something that I wanted to do for myself, and it was just fun. So that's why I advise you to do it. Just have fun. Let's talk about what we had here today. Okay, so we started with talking about the 2D game structure. We said about how we have the 3 different structures of the game. We said that we have the framework functions, which is everything that has nothing to do with the logic of the game. And these functions, if you write them well, it means that you can reuse them in a different game. Because it has nothing to do with the logic of the game, then it means that you're able to reuse those functions again and again, right? So the next thing that we had over there were the functions that has everything to do with the logic of the game. And this is where we started to understand that we're going to need this information in order to see what we're looking for in Clojure code. So then we looked at the game loop. We talked a little bit about how we handle input, update the player position, and redrawing it to the screen. And then after that, we talked about finding a 2D game. And if there's something that I want you guys to take from this talk, is this. If you're just starting out with Clojure, and it was not the smoothest ride ever, okay, then just go find a simple game, find a simple code example that works and that you can really enjoy looking at and start to explore it. Because if you're looking, you know how to code. I mean, if you already know how to code. If you're just starting to code, okay, that's a whole different story. But if you already have background in coding and you found it difficult to start with Clojure and you're looking at a simple code of a game, I promise you, it's going to change your mind. It's going to be magic, I promise. So the next thing is that you want to do is to map the game. Just like we said, we go over the different things. We make sure that we understand how everything goes in there. And then we want to add a feature. And here, I really want to say this. Start small, right? I did not start with Pac-Man. I started by changing the images, just to make sure it still works. Then I started by adding more directions, just to be sure that it still works. Every time that I added a little thing extra, that made me realize that I understood something new in Clojure. It's not simple, but it's doable. So then I said, okay, after we added a few features, we have a Pac-Man now. I said, okay, go write your own game, because it's going to be fun and it's going to be a lot of learning right there. And then that's it. We reached the Clojure star. It's amazing. So dream big, start with tiny steps, and I hope you guys enjoyed my talk. Thank you. Woo. Yeah, of course.
Why did AppsFlyer decide to use Clojure as a basic programming language?
Well, AppsFlyer started, I think, with Python, if I remember correctly. And there are different languages in AppsFlyer, but because we have to handle tons of data in AppsFlyer, so performance was the main reason, I believe, to use Clojure. And this was the language that was able to handle, I think, 80 billion events a day, if I'm not wrong. And that was the language that handled it. And they were looking for a functional language, and they wanted a language that runs on the JVM in order to have all the Java libraries right there. And that was Clojure. That was the main choice. Yeah. Yeah. And it's interesting, just so you know, most people that joins AppsFlyer, they don't always know Clojure. Like most of the time they don't. But in AppsFlyer, we learn Clojure. We have like a journey where we join AppsFlyer. We have like about 2 or 3 months that we can sit and learn Clojure, which is amazing because you're a programmer, you have your abilities, but then you're getting the opportunity to learn a whole different language in this amazing place. So, yeah.
Okay, how much did you learn first Clojure before picking up the game? You showed some sites, so I'm wondering. Or it was just a deep dive, show me the cow, I'll make it up.
So, like I showed the game, like the book written by the Clojure for the Brave and True, and it was enough just to understand the different concepts of Clojure, but not completely. I mean, it was like reading general information, which was okay. And then what I did learn was the syntax from the Clojure website. This was the thing that I actually did learn before I started with the games. So because I did a few of those questions in the Clojure website, I was able to understand why the plus sign is on the side, you know. But then after that, it's still not enough in order to start, you know, developing features in Clojure. And I did get all the time I needed in AppsFlyer, but for me, I needed an extra step in between, you know, between what it is that I do with the Clojure website until I develop a feature. Some people made it, you know, in a different way, but for me, I needed it as a stepping stone in between.
Awesome, thank you.
Thank you.
If no one else has a question. So you seem to say that in the beginning, learning Clojure was a bit maybe of a struggle because there's a different way of thinking, right?
Yeah.
And then once you get past that, it's fun.
But
does that different way of thinking, do you find now when you go back to program other languages that that other way of thinking is applicable there too, and it's changed the way you write in other languages?
So it's a great question because it did. I mean, it makes me think. So I said that Clojure made me start typing in my computer like a doctor. You know how they go like one, you know, just with one finger at a time. They really think about what it is that they're going to say. They don't just lash out at the keyboard. So this is what it made me do. It made me start thinking about every single thing that I do and see, can I do it in a different way? Can I not change this variable bazillion times? Maybe I can just define the data, you know, the variables in one side of the program and then use it in different places. I mean, if you need objects, then you need objects because it's in the language, but it's still, I don't know, it changed the way I define things to make it better. And I mean, I don't know, I love it now. Now when I see objects, I'm like, what? No. No, I don't need that. Yeah. Thank you.
So the core functionality of AppsFlyer is written in Clojure. Yeah, it's me.
Sorry.
It's me.
Yes. Yeah.
The
Sorry.
core stuff in AppsFlyer is written in Clojure completely.
Yeah.
And how about maintainability of this code? Because when you have like written a bunch of functions, like we've seen previously, it's like for me it's like very hard to understand what's going on like a couple of months later, because I have a bunch of functions chained to each other, and like objects for me it's more like understandable.
Okay, so first of all, that's a great question, because as somebody new that just joined the AppsFlyer, the first thing, like, you know, looking at functions, it was weird because I wasn't used to it. But not only that, I think that every code, if you write it good, then it's going to be understandable. And if you write with objects, you can write it in a messy way and nobody will understand what is this object. If you have like util, what is this, right? I mean, so you want to name your functions in a very understandable way. If I will look at this code even in years from now, even if somebody who doesn't really know how to code, it's written well, it's written simple. So you can always make code look, terrible, but if you, at the time of writing the code, make sure that you add enough comments, if you write it, very simple, and you divide your code into enough functions, then it makes it more clear. I mean,
So we have to be a good developer and
not just. You know what works for me? For me, it's just to divide your functions as to the smallest parts as possible. And then each time you can only understand one part.
okay. And another question. Well,
Take your time.
No, I definitely had that question, but I was like interrupted.
Well, you can
so
approach it
you're
later.
happy, and your team are happy with Clojure.
Yeah.
And well, let's say you're going to make a new startup. Will you choose Clojure for as a base language and framework for the startup, or will you choose something Clojure?
Yeah, I will definitely use Clojure.
So you're happy with Clojure. And which IDE you're using? IDE, IntelliJ Cursive.
IntelliJ.
So IntelliJ with Cursive plugin? With Cursive.
Yeah.
Okay, and it's going well, yeah?
Some people use yeah, so in AppsFlyer, we have Clojure, but we have so many other languages for different things that are done in AppsFlyer, right? It's not that just one language is for everything. Sometimes we need Python, we need Go, we have Node.js, we have Scala, right? Do I have it all? So I think I named most of them. Personally, I write with Node.js. I just started with Clojure, and I just started with Scala just before I came here. It was just the beginning. So, I mean, it's very diverse because you find out that different languages give you different things that they are good for, right? You can do everything with almost all languages, right? But if you find out the strength of a language that you want to use it for one thing, and this is what we do with Clojure. So Clojure will be the main language for handling data, transfer from side to side, handling the data in general. And then we have the front end, which has its own thing. We have a talk today about micro front ends.
Okay.
At what time? 2:25.
And another question, did you have some performance problems? Because as far as I remember, AppsFlyer is kind of analytics platform.
Right.
And typically you are receiving millions of messages from mobile devices, etc.
80 billion.
Yeah. So did you have some problems with Clojure? Because if you have immutability, you are constantly hitting the heap and garbage collector and all this stuff.
Not sure. Can you?
So you're doing fine. So immutability and...
We have, do you want to join in?
It's hard. There's a lot of hard work going into it. It's not simple. But people who use Clojure, myself not included, I'm not included.
Okay.
But they're all very happy with it. Our chief architect basically brought this into the company, and he's the reason that we use it. And I'm guessing this issue comes up a lot because it's very costly to train all these developers in Clojure. Mostly, as May said, people are not coming in knowing Clojure. Most people are kind of averse to list from what we see in college. And if you can see this going forward, when AppsFlyer has been around 5 years, no, 7 years now, I think.
Yeah, 7 years.
Then I think it's proven itself quite well.
Okay. And the last question, how about the REPL?
What about it? It's
REPL.
awesome. I like it.
You're using it constantly or?
Not constantly, but I use it a lot because sometimes I want to try something very specific and not run the whole thing. And with in my everyday, I want to try something very, very small, see if it works. So I would just take a small part of the code. I will run it in the REPL, see if it works. I know some people use it more, constantly. I'm not really into that, but I
you should
definitely
get used to. No?
So now I don't think I can do without it, to be honest. Even though I don't use it all the time, I don't think I can do without it because it's so easy and it became a part of my development process. Try this, see if it works, continue, move forward without activating the whole thing, right? So now, yeah.
Okay, thank you very much for great talk.
Thank you for coming. Thanks, everyone. That was awesome.